Alright, so today we have on the bench is an Alpine Mrv-1505. This was the predecessor to the Mrv-1507 amplifiers that you saw me fix. These amplifiers were awesome. I actually own one of these. I've had 2 or 3 of these in my over the years that I've owned personally and used, and they were great amplifiers. I actually liked these a little bit better than the 1507s, but the 1507s are great amplifiers when they're not blown. So yeah, this came in under the complaint that there is no audio, but it powers up. So we're going to be checking the audio path through the amplifier section. And first we're going to make sure, we're going to open it up and we're going to make sure there's nothing exploded, missing, broken, loose, you know, all the easy stuff. So I've already popped the bottom off of here, and we're just going to make a little, do a little overview of the rear of this thing. Let's see. This thing is a pretty big amplifier. It's probably roughly about 18, maybe 20 inches long. And look at that. That is beautiful. That is beautiful inside. It looks like nothing is, right off the bat, I don't see anything charred or crispy. But with audio amplifiers, you got to make sure that the capacitors are not pulled away from the board, because these are, you know, these things are in the trunk sometimes with a lot of you know, bass, and they do shake a lot, and that's why, you know, they put this elastic glue material down here so they don't vibrate. And sometimes what happens is the glue can break away a bit and the cap can start rocking, and eventually it'll vibrate itself to the point where it either just breaks the pin off the bottom of the capacitor, or it will break a solder joint behind the circuit board. And everything here looks okay in this section. You just want to give them a little wiggle. That's usually what I do, is give them a little wiggle if they start rocking. I mean, if they don't have this elastic material like this, these caps here, they're gonna move. But you know, the ones that actually have the glue on them, that were purposely glued, you want to make sure they're not rocking and rolling. And I'm just gonna go through the rest of these here real quick. Oh, see that? That's not supposed to be moving. I feel a little bit of rockiness on the pins. That's an issue. That's moving a bit. I mean, it could move a little, but I mean, it's supposed to move a little bit, but not a lot. And it looks like, I don't know if these caps have been replaced before. That's entirely possible too. I don't remember what the original caps were in these units, but I probably will glue these down if they check out okay. But this one here seems a little funky when I move it left and right opposed to the pins. So I'm going to check that one out. These ones still feel tight. Oh. That one feels very loose. This could be the issue. So we'll end up finding out if the capacitor has failed or it's a broken solder joint, might need some board work. So I'm going to probably not power this amp up at this point, because I suspect that there are some loose components and I don't want to risk damaging anything else. So the first thing I'm going to have to do is just pull this main power supply section. There's 2 sections here. There's an amplifier section from here over, and then there's a power supply section from here over. And I suspect that there might be a capacitor circuit connection issue here of some kind. So yeah, we'll start there, and of course I'm gonna go through and check all the FETs out and make sure nothing is shorted before I power it up. But you've seen that in my last video, so I'm not gonna go through that again, because that takes about 10-15 minutes, and I pretty much just went through it real quick on the last video. But after the cut was over, I went through it and really checked more in depth. So I think the first step here is to start stripping everything off from here over and getting this board up and finding out what's the deal is with these capacitors moving. These two outer end here ones are suspected to be the issue. Like I said, there's no audio, but it powers up. The power supply can possibly power up, but it might be only partially powering up, and that's probably might be the issue he was having with it. It was actually power light. It was enough to power the LED on it, but not enough to actually turn on the power supply fully. All right, so enough babbling. I'm just gonna pull this board out and find out what the deal is with that. All right, so I've got the power supply board flipped upside down on the Mrv-1505 here. We're going to check out those connections on those two capacitors that I suspected that might have some connection issues. And we're going to go to the microscope here. We're going to verify that if it's either good or bad, and we'll go from there. It's possible that either the solder connection has broken away from the solder joint, or the leg of the capacitor that goes into the capacitor itself has play in it and is broken away from its contact in the capacitor with the foil layer. So we're going to verify that right now. We're going to go under the microscope and take a look and see what we see. All right, this is the capacitor in question, the connection. And if you look right here on the left, let's see if I can do a point here. I do see a small ring around this connection here, and there's the leg right there in the center. I'm going to do a zoom in here so we can get a better look. This is where the microscope is nice. Alright, so now I'm going to stick a screwdriver underneath the board here and move that capacitor as we were when we were testing for loose capacitors and see if we see anything obvious. Look at that. That will cause intermittent issues right there, if not power supply not starting up correctly. Absolutely. So we're going to pull the solder off of this connection, resolder it, and glue these caps down. This is why I tell you that the capacitors that are supposed to be glued need to be glued. Vibration is a bitch. It will cause this all the time. Sometimes just the circuit vibrating itself, you know, as in if it's a PWM, part of the PWM, that constant high frequency vibration on the legs itself can even cause this over time. And heat and cooling, and I mean there's multiple things that can cause this. Let's go to the other capacitor that I suspected might have an issue. It was on the far other side. I believe it is this one here. Let's see, where am I? Yep, that one there. This is the other one I suspect that might be having an issue. Going for a closer zoom. Oh, I see a crack in that one too. Let's verify that that's moving as well. Yep, see it? See it moving there? So I'm going to end up doing this whole row of capacitors. Let's go back to the camera here real quick. Yeah, I'm going to pull all the solder off all those capacitors and check them and resolder them. And we'll give it a power up. I'll go over this whole board with a microscope, but again, I'm not going to show that because it just takes too long, and I don't want to bore the hell out of you guys. So I'm going to pull the solder up, resolder those. You know, I'm going to test them, ESR them. I'm sure they look fine, but that doesn't mean anything. So I'm going to ESR them and solder them up, and yeah, we'll give this thing a power up. That's all it might have been, but it might not be. It might be some other issue. I've seen how this happens 100 times. You think you got the problem solved, and this is just a problem that's been there for a while, and it's just never been, part of the, it's not part of the real issue. So I might solder these up, and come to find out, it still has the original complaint. So I will not be surprised if that happens. If it does fix it, and that's good. It's done. It's all set to go. I'll pull the board. I'll re-grease the heatsink and set the screws back down and give it a run up on the bench, and that'll be it. So I'll get this job done, and we'll see what happens. All right, so I'm going to show you an example of what I would typically do in this situation. I'm not going to show you all of them because it's just going to be very repetitive. So I'm just going to get these a little wet here with new flux. I'm going to hit it with some new solder. And typically, some people would only just do this, but it's not what you want to do. See, most people would just hit them up with new solder and let them go, and that's not what you want to do, because you're mixing that old crap up with the new crap. I'm just flooding the joint right now with new solder, so when I pull it up, I can almost ensure I'm going to get it all out of there. Most people would just do that, and hey, that might work for a good amount of time, but the solder is mixed, the lead-free is mixed with the new solder that has lead in it, and it's not, I wouldn't do it that way. I would just pull the joint up and start from a scratch. Now you can put some nice fresh solder on there. I'm going to put some nice flux down. Actually, before I do that, I'm going to clean the area and get it as virgin as I can. Now, if you look at that left connection there, it's going to take a fair amount of heat to make this connection a good connection because of the ground plane. This whole material here is wicking away heat from this joint. So I'm going to keep my soldering iron on there for a little while. And the same thing with the other joint there, if you look. Maybe that's the ground side. I'm not entirely sure. I haven't traced anything out, but again, I'm going to put some new flux down. Let me wipe this old crap off of here. And we're going to just lay this soldering iron on this joint for a little while before we flood it with heat solder, just to get it warmed up. And that's it. That should be good for another, I don't know, decade or two, who knows. I'm going to glue the capacitors down on the opposing side, on the other side of the board here, to ensure that that doesn't vibrate loose again. And yeah, we'll give this thing a run up after that. Alright, so I've made all the repairs on the capacitors. I have resoldered the connections. I have ESR'd the caps. All check out good. So yeah, I pulled the old solder up, put new flux and new solder down, and if this works, I'll just re-glue the line of capacitors back in the so they don't vibrate. But Yeah, we're going to give this a run up now on the supply. I've got it set to 13.8 volts, limited to about 3 amps. This particular one and the 1507s need about 3 amps to turn on, and then they idle back down to about 1.5 to 1.75 amps, somewhere in that realm, depending on the bias adjustment on the outputs. All right, so we're going to plug this in now. She shot up to 4 amps, back down to 1.3 amps. Now she's sitting there at 1.3 amps. So she's not running away in any current or anything. That I have 2 power lights here on the amplifier. I'll actually go to this cam here. Can't really see LEDs. Yeah, maybe you can. The two lights on the amplifier board are lit, so that indicates we have power there. I'm not exactly sure if that's rail voltage or a like low voltage control voltage power. So we're looking good there. Let's turn the signal on to the generator. Let's hook the scope up. And let's see what we get at the outputs. Ooh, nice. Nice, okay. That's it. We're gonna get nothing there. The grounds. We got output. Excellent, excellent, excellent. So that seems like it was the issue. So now I guess it's just a matter of gluing these capacitors down, and I am going to have to run this up on a speaker and give it a load test and do a thermal imaging of the outputs to make sure everything is balanced. And that's it. This thing might be ready to go out the door after that. So let's see what happens next. All right, I'm going to give this a run up on a small speaker and make sure I get actual audio out of the bridged output, and we'll play with the frequency generator a little bit, see what it does. I'm not sure if the audio is going to wipe out my mic, but it may, so I might warn you there. And you might want to turn the computer speakers down. So let's give this a shot. About 80 cycles right there. About 90 cycles. Let's give it a sweep. Let's see. Drawing about 8 amps right now. Nothing running away. So that looks good. I'll unplug this for a second here. Let the mic settle out. And all right, so yeah, I'm just going to run this up on that sweep cycle and let it run for an hour, and do a thermal over it, and if everything checks out fine, this is done. I'm happy about this. So yeah, I hope you enjoyed this video, and yeah, we'll see you in the next repair.